All right, guys, let's go over how to graph a linear function on a restricted domain. Okay, anytime we have a function, we assume that its domain is going to consist of all real numbers. So when there are no restrictions, we would simply write out the domain using interval notation as negative infinity to infinity, right? It can also be written using the symbol for all real numbers, which is this R. It appears like the paragraph symbol. It's just a R with two lines on it. Okay, that's all real numbers. Now, I had already filmed this for you guys, which is why my notes are filled out, but I have no idea what happened to the video, so I'm going to try and explain this as best I can with my notes already filled out. So when you are given a function, you are going to be given the domain along with it. Okay. In this case, it's written in interval notation from -4 to 4. So it makes it easy because you can see that we have two endpoints, right? One of them is going to start it, one of them is going to end it. What we do is we take each of these points and substitute them in for x, simplify the function, and it gives you the value. So we have a coordinate location at -4, -1. Do the same thing with the second endpoint, substitute, simplify, and solve, and we have another endpoint at 4, 5. Now, when you are given the domain in interval notation, remember to look for brackets or parentheses to determine if your points are included or not included. In this case, they are both brackets, which tells us that they are both included. So we use closed circles on both ends, connect them, and you have your function. It begins and it ends. Range is always written from bottom to top. So if this is our range, we read it from here, which is -1, and it ends up here at 5. Interval notation from -1 to 5. Both of them use brackets because they are both terminating. Or sorry, they are both included in the function. Now, what happens when you are not given both endpoints? Okay, for B, we have our function, -x minus 2, and our domain is x is greater than -3. Well, we have one endpoint, right? -3, we can substitute it in for x, simplify, and you can see that we have a point at -3, 1. Looking at my inequality symbol, it's just greater than, so I know it's not going to be included. So we use an open circle when we graph it. Now, how do we determine where or in which direction our line goes? Okay, if my domain says that x is greater than -3, that means that all the values of the function have to be to the right of -3. Okay, so there's two ways you can proceed with drawing that line. The first way is to use the y-intercept. I can plot a point at -2 and you can see how easy it would be for me to draw my function that way. Second method is to use the slope. Okay, in this case, remember mx plus b, m being -1, I can go down 1 over 1, and you can see that my function we're able to graph the function. Okay, now in this case, the range, again, we always read it from the bottom up. In this case, we don't have an endpoint, it's going to continue extending on. So we're coming up from -infinity up to 1. Okay. We are asked to write it in set notation, so I wrote it as y is less than 1, or you can write it as using infinity, -infinity, less than y, less than 1. Okay, remember that is always an option. For C, again, two endpoints. I took -6 and 6 and I substituted them into the function for x, simplified and found my two coordinate points, -6, 5 and 6, -1. Now when graphing, look at your inequality symbols. You can see that -6 is going to be included. So -6, 5 has a closed circle. +6, its x is less than 6, it's not included. So 6, -1 has an open circle. But again, endpoints are easy. We just connect them and we have our function. To write the range in inequality notation, we still read it from the bottom up. So here's my starting point at -1, and I'm going to extend it all the way up to +5. Okay, as in inequality, -1 is less than y, less than or equal to 5. All right. All right, now go ahead and try the next 3 problems on your own. Come back and look at the work and make sure you did it correctly. This is what you should have for D. You had one endpoint that's included at 3, -3. So here's my point. And the domain tells us we go from -infinity up to 3, which means that all of this is where our function would be located. Okay. Now, if you use slope, you couldn't go down 1 over 1 because it would not fit the domain. So we would go in the opposite direction, up 1, or sorry, 2/3, not 1, up 2 over 3, up 2 over 3. Or again, you could have used the y-intercept at -1, plotted it, and drawn your function. The range starting at -3, and this continues on. There's no endpoint, so we go up to infinity, not included. Second one had two endpoints. You should have a point at -1, 5 to -4, open circle, or sorry, close circle at 2, -4, open circle at -1, 5. Range bottom to top, so -4 up to +5. -4 is included, 5 is not included. And the last one, you should have one endpoint at 4, located at 4, 1, so closed circle, it is included. And then using slope, down 1 over 2, or using your y-intercept at -1, you can draw your function. Writing out the inequality in interval notation. Remember, we're coming from the bottom. We don't know where it's going to end. So we come up from -infinity up to 1. I should say 1, not 4.